Consider the case where I have a very large document with multiple pages and you want to summarize. We've seen in the previous video, all I need is a load summarize chain, which is very specifically written for the summarization purpose. What does it do? It takes the summary of different documents and then combines it and gives us into one single summary. Let's consider a use case which requires information from multiple pages in a document, but for a use case which is not summarization, which means you cannot use the load summarize chain. So let's see under the hood what happens when you want to do the same operation over and over again on multiple pages in a document. Let's take a use case where I have multiple documents and I want to extract the keywords from the entire document. To perform this, we are going to make use of the MapReduce framework. Initially, we go through a map phase in which from every single document, we take the list of keywords and then pass these keywords through a reduce phase in which consolidates all the keywords, filters the required keywords and gives us one single list, even though the keywords are coming from multiple pages in the document. We need to install Langchain because that is the framework we are using. The LLM model that we are going to use is the GPT 3.5 Turbo from the OpenAI. We are going to get PDF as input, and so we need PyPDF. And to perform this MapReduce work, we also need PicToken. Let's authenticate the model by giving the openai.api key. Insert your key here as a string or as an environment variable. The OpenAI model that we are going to use is the chat OpenAI. The OpenAI model that we are going to use is GPT 3.5 Turbo. So since we're using a chat model, we call the chat OpenAI class and create an instance. First, let me give you an overview of how the MapReduce framework is to be implemented for this use case, and then we will start looking at the code. I need to write two prompts. One is the map prompt and one is the reduce prompt. It is in the map prompt that we say that from every document, I want you to take the keywords. And then this we implement using a sequential LLM chain, a simple chain. But the input to this prompt should be the list of documents on which we want the MapReduce framework to work. The output of this map prompt will be a list of keywords. These keywords have to be given as input to the reduce prompt. Remember, the reduce prompt is not taking the documents, but rather the output of the map prompt. And now in the reduce prompt, it takes the list of keywords that you have split in the various documents and then consolidates it. For this, it has to be first given through a normal LLM chain, a sequential chain. The list of keywords that we have got from every document has to be stored in something called as a document variable name. And let's say the variable name is docs_keyword. This document variable has to be given to the stuff documents chain. Now, what is stuff? I have the prompt and I have the corresponding text. The list of keywords along with the prompt which says, take these keywords and perform the following. That has to be given as input to the stuff documents chain. Remember, when the chain type is stuff, the entire prompt is given as a single input with the prompt and the context on which the prompt is run. The stuff documents chain has to then be passed through a reduce documents chain. And then finally, the output of the reduce documents chain should be passed to the MapReduceDocumentsChain chain. Let's look at this with the help of an example. The first step is to create the prompt template So I say list all the technical words in the text provided. Do not add any other information. And this is the entire list of documents as document objects. Step 2, you create a prompt template. The instance is map_prompt. And to create this instance, we call the from template method, which takes the prompt string as input. We then pass the prompt through the LLM model. This is a simple sequential chain. There are a sequence of steps involved in the reduce phase. The first is to write the reduce prompt, where we say, what I'm giving is a list of technical words, and that is produced as doc_underscore keywords. Remember, this is a document variable name. I want my LLM to take the different keywords and distill it. The minute I say distill, I want it to filter and give me a final consolidated list. Very specifically, I have asked for the list in alphabetical order. As usual, the first step is creating an instance for prompt template using the from template method by passing the prompt which is required in the reduce phase. Then we create a sequential LLM chain by passing the prompt and the LLM model. This is the same step that we followed in the map phase also. Next, we are going to take the list of documents, which is we are going to take the list of all the keywords. How do I know I'm taking the list of all the keywords? Because I've said that the document variable name is doc_keywords, and this is exactly what I have given here as my parameter. So I call the stuff documents chain, which will take all the keywords from the different documents. It will make it into one single list or stuff it into a single list of keywords. And along with the prompt, which is a reduce prompt, it gives it to the LLM model. And the stuff document chain has to take the reduce chain as one argument, and compulsorily the parameter which is there in the prompt should be given as a document variable name. Step 3, we have multiple keywords being stuffed into a single prompt with a prompt which says now list everything that is only required and in alphabetical order. The reduce documents chain is the one which will reduce all the mapped documents. That is, the list of keywords from the different documents have to be reduced into one single list, for which we make use of the reduce documents chain. In the reduce documents chain, we need to give the instance of the stuff documents chain, which means we give all the keywords along with the prompt as to how to reduce. But it is totally possible that when we do this step, the number of tokens becomes larger than what can be handled by the LLM. So in this case, I also make it go through a collapse document chain. That is, I mention that when the prompt exceeds the required number of tokens, then it has the ability to split it into multiple documents and recursively do the reduce work till it gets the final result. And it says that when I split the list of tokens and the prompt into multiple documents, the token maximum that I take is 4,000. I have separately done the map phase. I have separately seen how to handle the reduce phase. So for that, I make use of the MapReduceDocumentsChain. All these chains are present in Langchain.chains. So where we can find the stuff document chain, the reduce document chain, and the MapReduceDocumentsChain. To create the instance of the MapReduceDocumentsChain, we need to pass the map chain, and we need to pass the reduce documents chains instance, the input document as the document variable name, And if we want to return the results of the map steps, I have said that I do not want the results of the map step, and so I have given it as false. We have seen what to give in the map phase, what to give in the reduce phase. Now let's give the actual documents into the map phase. Let me take test.pdf and then convert it into document objects. There are 148 document objects. I need to split my text so that it is well within the token limit specified by the LLM. Let me make chunk sizes of 1000 with a chunk overlap of 0. I have multiple pages, and for the testing purpose, I need only one single page. If you want to pass the entire list of documents as input, I can give docs is equal to text splitter dot split docs of data, where data is my document object. If I want only a single page out of the entire data in this line, the data object at the 100th position, when I take the page content, it gets split into multiple text lists. I take each of it. For example, in this particular case, I have 3 splits of the page content in the 100th page. I take it split by split, and every split I convert it into a document object using page content is equal to P. Now I have a list of document objects. This list represents one single page content in my data. I run the MapReduceDocumentsChain, which is the instance of the MapReduceDocumentsChain, and I run it with the documents. I have asked it to list the technical words in alphabetical order, and so I finally get this as my output. You might be wondering that we have not used vector stores and embeddings. In this particular use case, I want every single document object, and so I have not used vector scores or embeddings. But if your use case necessitates certain documents for the output, then in that case, we can make use of retrievers and generators. Thank you.